So far we have seen and used functions and procedure calls, and we have passed either none or multiple parameters into both functions and procedures. Up to now we have used a very simple method of passing parameters. We have simply passed in values from the calling code, which are then assigned to local variables within the function or sub-procedure, and when stepping through the programs using debugging, we can see how those local values are then stored and accessed for the function or procedure, and that's it. But there are other ways in which parameters can be passed into functions and procedures, principally a term known as by reference, and this is different to by value in terms of what is actually passed across to the function or sub-procedure with the parameter call. So when we pass a parameter in by value, this is the default. If we don't tell it otherwise, programming languages will assume we mean by value. Then what we are doing is, when we are calling the function, we are saying when you make a call to the function, pass across the value that is currently stored in this local variable and assign it to a new local variable that is going to be created when the function or sub-procedure starts execution. So the actual value in the variable in the calling code, where the call to the sub-procedure or function was made, remains unchanged. Its value is effectively copied and passed to the function or sub-procedure. So once inside the sub-procedure or function, that local value may change, may get altered, it may get changed, it may get reset, reinitialized, who knows what. But when that function or sub-procedure exits, then all the changes to those local values are lost, and when the program returns to its calling code, the variables that were included as parameters still have the values that they were given before the function call was actually made. So this is the usual way in which values are passed into procedures, and it's a fairly straightforward method to grasp. So here's an example. We have some code input, please enter a number. So we ask the user to enter a value stored in a local variable called num1. We can then output to the user that they entered a value and echo that back to them so they can see what that value is. We'll then make a call to this sub-procedure called calc square, and we give it one parameter, which is num1. So inside this sub-procedure we also have a local variable. Notice this is slightly different. This is a different name, numin. So this definitely is a different variable to that one. And inside here, this variable numin is squared. It's assigned a new value, which is the result of itself multiplied by itself. And inside this function we can then output the value of that calculation. So print the squared value in the sub-procedure is, and then output the new calculated value. Our sub-procedure ends and we return to our main program, and num1 will be unchanged, despite the fact that in the sub-procedure the parameter it was passed across as was actually altered, and in here it will still have its original value. So let's go across to just basic and run that program. So let's input 5, for example. Thanks, you entered the value 5. The squared value in the sub-procedure is 25. Back in the main program your number is still 5. So let's step through that just to see what's going on. So we're going to enter a number, in our case 5. We can see that num1 is then given the value 5. We can output that to the screen, so we can see that that value has been output. We're then going to make a call to this sub-procedure, and we've passed across num1, which has the value 5, and we've then got a new local variable called numin, which has got the value 5. We can then assign numin a new value, which is the result of itself squared, and then print out that value. So we can then see that 25 is used in the output statement. We can then return to the calling code, and we can see that num1 still has the original value 5. Okay, so we can see how that works. So if we try and do a similar thing but using by reference, then we can start to see some changes. So when values are passed into procedures by reference, it isn't the value of the variable that's passed across, it's the memory location of where that variable is actually stored. So it's the address of the variable in memory that is passed across. When a local variable is used within the function or sub-procedure, it can then refer to the same memory address, so the reference is the same. So any changes to the value in this local sub-procedure or function then get changed in the same memory address that is being referred to by the original variable. So in other words, two variables are pointing to the same location, and therefore those changes are reflected in both values. So this can be used to change several values of passed-in parameters into sub-procedures. So we can pass any number of parameters into a sub-procedure, and any of these could be by reference. So care must be taken, however, because when using by reference, variables can be changed from several places in a program, which can, under some circumstances, make debugging quite complicated. So this is a very similar program to the previous example, but this time the difference here is in the definition of the sub-procedure. We have the use of a new word, by ref. So it's telling just basic that this sub-procedure, calculate square, has one parameter which is passed in by reference, and the rest of the program is virtually identical apart from some text in the output messages. So if we pass across to just basic and we paste over this code, so there's the keyword by ref, and we run it this time, then we can see that the entered value is 5, the squared value in the sub-procedure is 25, but back in the main program the number is now 25 also. So let's step through that program and see what's going on. So we'll enter our input value, which is 5. That is assigned to the local variable num_in. We can then output that to the screen. We can then make a call to num_in, and this call is then made by ref, so the value of where num1 is actually stored is being passed across rather than the value of it, which therefore means when num_in is declared, it already has a value. It isn't initialized to 0, it has a value. It's the value of whatever's in the memory location at which it is pointing. So that calculation carries out in the same way, so num_in is squared, and the value is stored in the location to which num_in is pointing, which is the same as where the parameter that was passed in is pointing. So when this function finishes and returns, we can see that num1, if you were quick there, you could see it changing from 5 to 25. So the value has actually changed in the memory location. So it's quite a powerful feature. But you might be thinking, well, why do we need that? So we know that we can write special procedures known as functions which return a value when they finish execution, and for example our squared function as it stands is pretty useless, and we saw earlier on in this lecture that we can write the squared better as a function than as a sub-procedure. So this is the calculate square now written as a function, as we saw earlier in this particular session. So instead of doing a call to calculate square, we simply print out the result of calculate square. So calculate square with a parameter returns a value which is output. So we might also want to assign the result of that function to a variable in our program, and again our earlier example showed that the value of, or the value returned by calc square could be assigned to a variable. So if we can pass values back from functions, why do we need to be able to change the values of the parameters that are passed into functions? Well, the simple answer is we mentioned earlier that functions can only return one value, and if we want to actually maybe change more than one value in a function, then we can't return more than one value, so we have to use an alternative method. So by passing in parameters by reference, it enables those values to be actually changed in the function without the restriction of only one value being able to be passed back. So we'll have a look at a worked example of this to get a better idea about how this works.